welcome. We just started. Today we speak about the hackathon in particular, but also provide a little bit of more information about the Cassini program. But before we go into the topics for today's webinar, I would like you to ask to mute your microphone. And in case you don't want to be recorded in this webinar, then switch off your camera. The webinar will be made available afterwards, so you can do the playback and also invite your co-workers, colleagues, or friends to have a look at the webinar. So maybe they get inspired and register for the hackathon. And before we start with the speakers out today, I will share my screen and then do a bit of a presentation about the Cassini program. So not in presenter mode. This should be solved. Yes. So here we go. Today's topic is EU space applications for defense and security operations. And as said, it's a preparation for the Cassini hackathon. So today we have two speakers and two companies. The company OpNet, not represented by Seva, but represented by Barbara. And we have the company Smooth Stone Dynamics, represented by Bram and Tristram. And there's an opportunity after the presentations and Q&As to have a pitch for ideas or for insights which you want to share with the audience. And then we conclude, and this should be done at about 6 o'clock. So I suggest we do the questions after each company presentation. And there's always an opportunity to put the questions in the chat if possible. So a little bit of information about my organization, dotSPACE. We were founded in 2016, and we act like a market maker. So we connect the partners in the quadruple helix framework, so industry, government, university, and society, and specifically focus on applications of space data. Can be different sectors, and we provide in 3 categories: services, engagement, open innovation, and capacity building. And this perfectly fits the reason why we organized the Cassini Hackathon for this year. So some background about the Cassini Entrepreneurship Initiative. It's a program of the European Commission focused on the innovation and stimulating entrepreneurship in space-related fields. So it's the support of startups, SMEs. It's about getting projects started. It's about scaling up projects. So there are different programs and prizes, but there's also a large investment fund in the Cassini program. And the hackathons is a core element of the program. And this specifically is creating awareness and get people acquainted with space data in the domains of Earth observation, navigation, and satellite communication. And the hackathons are organized given a specific topic. And the topic for the 8th hackathon series is security and defense, which we will discuss later. So what can you expect in the hackathon? It's a weekend full of innovation, problem solving, creativity, and also a lot of networking opportunity, meet nice new people. As of today, there are already 40 registrations for the hackathon. So I would say the more the merrier in this respect. The event will take place in Zoetermeer at the Dutch Innovation Factory, and in the weekend of 22nd till 24th November. And you can join physical, but also in a virtual environment. If you want to register, you can do this. Slides will be sent afterwards. and you can follow the links, and then it's easy to do so. So, well, some highlights of the program. We start with a networking and challenge development event. And then at 7 o'clock, there's the official kickoff of the hackathon. On Saturday, it's a full day of coding, and on Sunday, the awards will be given to the winners. And on the right, bottom right, you see an impression of the 6th hackathon, which we organized last year together with a partner, Royal Haskoning, and this was in their head office in Amersfoort. So these are the 3 challenges. Today we discuss a little bit more on challenge 2, but also challenge 1 will be addressed. And in the webinar of next week on Tuesday, challenge 3 will be addressed. So besides the challenges, there's also a complementary package, which is we accommodate your stay in Zoetermeer. So it's 2-night stay in the Golden Tulip. You can make use of the bike, so you can go from A to B. Meals, refreshments are included. Barbara will speak more about the use of the OpNet platform. Then datasets for the 3rd challenge are provided by CNES, and the French company Keynote is also delivering hardware and gives you the opportunity to connect to their satellites when they have a passover. And teams can be formatted via the Taikai platform. You can register as an individual and then format a team on the platform. So there's some local prizes. We grant the winning team €1,000, the runner-up 500. Different pitch opportunities, and as it is a European competition being organized simultaneously in 10 countries, the winner will be chosen from all these local organizers, from all these local events, and the overall winner will be awarded with an additional grant of €5,000 and a number of mentoring and expert hours from the USPA network. So what's next? Next webinar, as I said, it's about the 3rd topic, space situational awareness. The first speaker is confirmed. It's from the company eCosmic. They will speak about their solutions for collision avoidance mechanism and software. And we hope you all will register for this webinar as well. So please reach out for any questions. This can be done in the chat. And here are already the email addresses of the people who will speak afterwards. And then let me invite Barbara to start the presentation for OpNet. So, and I will stop sharing right now and then see if more people are in the waiting room.
Yeah, so I just wanted to tell you because my colleague just asked me that he's in the lobby.
Yeah. Okay. I couldn't see it because of my screen, so this is a bit of a downside, but doesn't matter. So welcome everyone who just joined. We just concluded on the general introduction, but don't worry, I will send you the slides afterwards. So you have all the information available and email addresses are there, contact details. So in case of any questions, feel free to reach out, and I'm happy to answer the questions to my best of knowledge. Barbara, the floor is yours.
Just to confirm that I am sharing my screen?
You are.
Yes, thank you. Okay. So, hi, hello, everybody. Thank you for joining this webinar, and thank you for the opportunity to present the work that we do in OpNet. Just to give you a bit of a background, we are a Dutch SME, and of course, there is a lot more information about the history of the company that you can find on the link that I presume you are seeing on my presentation. But since we do not have a lot of time, I would like to present to you just a short description of our main product and the platform that we are offering. So very quickly to go through the intro. So what do we do? So we have developed something that we have called Monitored AI Platform. So it's a high performance, high computing geospatial platform that is capable of processing, combining processing and automation capabilities of AI with the solving natural problem solving abilities of humans. It has a number of functionalities, but just to kind of quickly sum it up, it can do pretty much everything coming from data acquisition, from multi-source data, through data fusion and a complex data searches and visualization, all supported with AI LLM. In this case, it is Amazon's Bedrock. And all supported with something that we call AI knowledge packs with their specialized input. But to put everything in a bit of more perspective and to dive into a bit of more details about what platform itself is, I would just like to, first of all, start with what are the basic platform roles. So on a platform, you can be a data provider, a data processor, a data publisher. That is the standard on platform default roles. So you do everything from acquiring the data, processing the data, visualizing and publishing the data on the platform. There are multiple other possibilities of different combinations, but always the data publishing itself goes through the platform. But I keep saying this monitored AI, but kind of try to explain a little bit more what it is. So it is a platform that has three main components. The backend component, which we have named Oakley, the front-end component, which is a web UI, and a data repository split into two parts. So cloud object storage and metadata database. A bit more complex and going into a bit more detail, you have from one side input of data to the platform. This data, as I mentioned, can be multi-source data since the platform is data agnostic. The data is inputted into the platform, into the backend, and there we have, and I will go into more details about that, something that we call AI knowledge packs, which perform everything from data acquisition, pre-processing, image processing, analysis-ready data creation, AI analysis, and publishing. So everything is done in a streamlined fashion, end-to-end, in the backend. The backend communicates with both data repository and the front end. As I mentioned, there are two types of data repository, and each of those data repository communicates through either middleware or a tiler with a front end, which then has the possibility of web-based visualization in cloud optimized GeoTIFF file format with OGC web services, and of course assisted with a conversational AI assistant, as mentioned in the beginning. This would be a bit more complex type of architecture that I will not go through now. But if there are any questions related to the platform architecture itself, and a bit more detailed explanation is something that you are interested in, we can always come back to this slide and explaining into more details later. But to go now into a bit more detail to each of those three components of the platform that I have mentioned, the backend, or Oakley as we have called it. So what is it actually? So it's a backend system that orchestrates data processing and the automation of functions. It is facilitated through comprehensive workflows that are defined as AI knowledge packs. So each task that is started in your backend inherits the selected AIKP properties by becoming the instantiation of that AIKP. So it's a backend component of the platform that processes multi-source data, performs complex analysis as tasks, which use AI knowledge packs for a given region of interest. That is kind of like a little summed up part of what the backend system does. So I mentioned a couple of times that the platform is data agnostic, so it works with multi-source data. What does that actually mean? So the processed input data can be drone imagery, it can be proximity sensors, or it can be Earth observation satellite data. Speaking of those, and also UAV images, it can be both SAR or radar and optical, multispectral, hyperspectral, commercial, or open source imagery. So as I mentioned, data agnostic. I also mentioned a couple of times this term AI knowledge pack. So to kind of give you a bit more of an insight of what it is, an AI knowledge pack is a automated, self-contained, and linked Python software module that does data finding, acquisition and ingestion, data fusion, pre-processing, AI processing, and everything is concluded in publication of your newly created AI product and its associated metadata into their respective data storages. So as I've mentioned, it's an end-to-end solution. The knowledge packs itself, or the backend, comes in, let's say, two flavors. So a pro version and an open source version. The difference between them is the pro version uses proprietary tile-wise processing, which reduces the time and the memories used. And we currently have more than 20 developed AI knowledge packs, which you can see on a table on the side, kind of giving you an overview of the topics or the issues that the knowledge pack itself deals with and the type of data that it uses. We also have an open source version of the platform, which only has certain limited capabilities, but still strong enough. Each each of this knowledge pack that you can see here, both pro and open source, follow the same pipeline workflow list of steps that you need to follow, but the general flow in general of your knowledge pack or your work in the backend consists of these several steps as you see them here. So it starts with your setup, the selection of the knowledge pack that you want to use, your region of interest that you want to use, the initiation of the work itself. Then the data can be searched either through internal finders or inputted directly. The data is ingested in some of the file formats that satellite data or UAV data comes in. And then this is the most important part, or the crux of the platform itself, is the creation of analysis-ready data and AI analytics. So this analysis-ready data is a key step in AIKP-based workflow. So after the data is ingested into the platform, it is normalized and pre-processed, meaning that there's an automated flows that allow users, the backend users, to skip a lot of manual steps of work with this pre-programmed type of codes that help you create your analysis-ready data in two steps. So first, you have something called stacks, and then you have something called tensors. Stacks refer to geometrically aligned channels without any specific filtering or scaling. They're all in the same resolution, same size, and aligned to a pixel-to-pixel correspondence. They are made with something that we call processors. And after that, the stacks are built on top of them. So think of it as level 3 data. And on top of them come tensors. So tensors include some more complex pre-processing steps, which include things like log scaling, cropping the outliers, filtering, detecting bad pixels, and satellite-specific procedures, or also AIKP specific procedures. So something that you want to be done on your data to prepare them for further analysis. Think of that as level 4 data. So that data, on top of that, the workflow after you have inputted your data, made your stack, made your tensors, you come to either directly visualization of the tensors that you have made, or performing an AI analysis of your choice on the created tensors and publishing then the result of your AI analysis. Everything finishes, as I already mentioned a couple of times, in the upload of your created AI product to the web UI and the metadata to its respective database also. This is kind of the same workflow that I showed you just now, just separated into certain parts. So you have your starting initiation of your task, you have setting of your task-specific parameters, you have the creation of your analysis-ready data. One of the most important steps, as mentioned, creation of your stacks, creation of your tensors. Optional AI analytics, depending on the AI KP used and its intended use case. You have your visualization and you have your publishing step. I will also go through this part a little bit more quickly, but oh, sorry. I am sharing that. This is also a part what is a flow. So what we are offering here is a structured way, an end-to-end way of doing your geospatial analysis based on multi-source data, which is faster, easier, and more in line with the, let's say, the idea of the hackathon. This again is a bit more complicated slide, for which I, for the sake of time, will not go into details, but we can also go through it later if there are somebody interested in this. But what is, let's say, the point of all of this? Well, the point of all of this is to show you that with the input of your domain-specific knowledge or the problem that you want to solve during this hackathon and the existing AIKP structure that we are offering here that solves parts of your problems that you do not have to deal with, but you can focus on the point of your problem that you're trying to solve. When you combine the structure and your domain-specific knowledge, you can have a very fast way of creating new, relevant, needed, and useful AIKPs first for the use in this hackathon. Everything at the end comes to the front end. The front end is the nice visual part of the platform. So what is it? It's basically a general repository of data, which is easy and quick to interactively explore. It is web-based, so there is no need to download and set up any specific software. It's a comprehensive solution for geospatial data management, processing, and it leverages advanced technologies, cloud storage, compliance with industry standards in order to empower users to work effectively with geospatial insight. It is user-friendly. It has both 2D and 3D visualization capabilities. And as I've mentioned before, it has advanced querying options with AI assistant based on Amazon's Bedrock. This is kind of a static screenshot of how the front end looks like, but I will not spend some time here because I have a video that, if we have time, I would like to show you that kind of gives a tour of the front end. And lastly, very quickly, as I mentioned already a couple of times, we have these data repositories. So you have cloud object storage for your AI analysis output, so in COG file format, and you have the metadata in a GeoJSON file format that is in PostGIS. But again, I would like to emphasize kind of like this as one of the most important parts of the platform for the use in this hackathon. And now, if we do have time, can somebody please tell me if we do have time? I have a short
how long is the video, Barbara?
4 minutes.
4 minutes? I can do, yes.
Okay. Okay, thank you. So then, I'm sorry, wait a second. Do you see the video?
Yeah.
Okay.
it's not playing yet, but
yeah, it's not playing, but you see it. Okay, so I will start the video. As it is mute, I will kind of talk over it to kind of explain what is happening. So as you see here, this is our front end, and the bottom left corner is the AI assistant, which you can talk to. You can ask it who it is, what it does, and you can ask it to show you all the data that is published for a certain region. So I'm asking it here to show me everything that is published in PS Salmi, for example, in Finland. And what it does, it gives you everything in the data repository in a tree-like structure that you can explore with seeing the visible metadata through the information icon. And every file that you click on is added to the main map screen, and also on the right-hand side on the viewing pan. As you see, I'm kind of going through the random data that I want to add to my screen, that I want to visualize, but also inspect and do certain type of analysis on top of them. So here I have added everything that I have wanted, and now you can switch back to everything that is visible in your viewing pan or in your map view. You can always change the position of the layers with a simple drag and drop by making it enabling or disabling visibility. You can also play with the transparency, opacity, brightness, and contrast as a standard visualization tools. And here you can see using the lens tool. So lens tool is something, and multi-lens tool is something that is used to drill through the top layer of data so you can see the data visible below. So this is me playing with a bit of raster data and showing you the capabilities of the raster data. But I also, we can also do different data types. So here is an example of how it works in 3D with DEMS. So these are two DEMS stacked one on top of each other with a pixel-to-pixel correlation, different resolutions to them. Certain data types you can play with changing your color maps to however it you find best to see. But what is one of the most interesting things here is the delineation by contour line. So if you want to expect just a certain range of elevation, you can set it here in this part of the DEMS themselves. Of course, there is a legend that shows you the minimum and maximum values of every data set types. And we also, so there are full 3D capabilities of the platform. They are not shown here in the videos, but it is possible to have full 3D objects both above and below the ground. One of the last things that are shown in this video is how, for example, you can use smaller areas of interest and calculate certain parameters on top of them. So this is soil moisture that is calculated based on Sentinel-1. And just by clicking or choosing which of the fields that I want to visualize, you get a graph similar to this, which shows you the calculated values of the parameter, in this case, soil moisture, for certain times when the Sentinel-1 image was taken. You also can maybe see that I have changed the base maps. So the base maps are something that can be additionally played with, and you can personalize your view of the platform and the map view. So this is, for example, open topo. There is a water terrain, which can also be useful. So depending on the use case, a lot of things can be added to the platform itself. And with that, I think I have stopped sharing, and I think that both me and my team would be very grateful for any questions that you might have for us in general to explain a bit more if I maybe rushed through certain parts.
Thank you very much,
Thank you,
Barbara. Thank you. So I would like to add a little bit to this presentation. I'm CEO and CTO of OPNet, and I wanted to extend the actual offer to the participants or those who think about participating in Cassini Hackathon. So all parties who desire to participate and use the platform will receive free access to the backend and front end during the Cassini Hackathon, and in preparation they will receive training. The credits for your compute resources, and in this case, you could have massive computational power. You know, your data sets could be literally tens or even hundreds of gigabytes. We are not limiting you with any pixels sizes or any area. If the only limitation is that you will have the open source version of the platform installed, and you will have open data access. So there will be no commercial data during the hackathon because we are not a satellite imagery provider yet. So maybe in the future, but in this edition of Hackathon, we only provide you compute and the platform capabilities plus training for free. And I would like to add that all this became possible through our collaboration with our partner, AWS, who will provide the credits necessary to run your compute jobs. So you could imagine the platform like this for the hackathon could easily cost about 1,000 euros. So you get this all for free for the participation in the hackathon. And also, I hope this would help you to create new innovative use cases and implement your ideas in a fraction of time, because some of the ideas could be implemented in minutes rather than months if you would start from scratch. Well, thank you. And if you have questions, we are happy to answer them.
Barbara, thank you very much. And thanks for this generous offer. So I don't see any question in the chat, but maybe participants want to just unmute yourself and ask a question. Don't be shy. You can think about it and I will ask the first one. So Barbara and Taos, you mentioned it is the free version, and I saw also in the demonstration on you or the animation in YouTube, I saw Sentinel-2, 1, and Landsat 8 as a source. You spoke about your ambition of being a data provider for a few years. No, but what, for example, if I have the open data portal from NSO, can there be made a match, or can participants use the data from that source as well, or?
Yes, absolutely. If participants have their own data, they could upload it. So for example, the Challenge 2 participants may have the drone service or some data they acquired during the hackathon, and they would want to upload the drone data. Or, like you mentioned, download the data from NSO Space satellite portal. This would need to be manually uploaded into the platform, but you're not limited for that. So the data sizes, as I mentioned, could be quite substantial. Each participant will get 100 gigabyte by default. If you need more, let us know. We could also arrange that. And you would also have unlimited CPU compute power. So, well, of course, it's limited to the time that you have in the hackathon, but there would not be special limits applied. So you will have these virtual machines, Docker containers, which each would have 4 virtual CPUs at least, and 100 gigabytes of storage, plus, I think, if I'm not mistaken, 16 gigabyte of RAM. So this is like getting your own high performance compute machine with the access to data. Free data from open sources is automatically ingested into the platform, as Barbara explained. The acquisition. So all you need to specify is the area of interest and region of interest, and the satellite, and you will have a training. So then the system will fetch the data for you. But if you have your own data, which is not automatically fetched by the system, this is how you do it. You just upload it into your working area. Plus, I want to mention as well that your data remains private through the duration of the hackathon. So other teams cannot see what you're working on. So you will be working in your secure private environment until you publish your results. The published results will be viewable by judges and other teams and your fans. So the published results are designed to be freely open to everybody. That's the idea of hackathon anyway.
Yeah, and to add a bit on this, the team is the owner of the output. So this is one of the rules of engagement for the hackathon. So okay, in case there are no further questions, you can always ask them in the email or on a different time slot. So we will sure that they will reach the right people. So then again, thank you, Barbara and Taras, for your presentation and explanation. And looking forward to see you and join us in the hackathon in the weekend of the 22nd of November. We'll promote, of course, the platform and hope we get a lot of users. So that's a challenge for the both of us. And then quickly move on to Tristram and Bram from Smoothstone Dynamics.
Thank you very much.
Thank you, Taras, which is the second speaker for today. They ask, there's a welcome, the late visitor. So I'll move to start sharing my screen again, because then the floor is yours, Bram and Tristram. Let me first share.
I'm not seeing it yet, but
The screen. Here it is, and then we move on. Go.
yes, thank you. I assume that you, when I say click, that you click. This is not what
Just give
we.
me a sign. If you say click, then I'll click on the click.
Okay, perfect. Hello, everybody. Thanks for joining in for this amazing hackathon. It's our first hackathon, but we like the idea, and that's the reason why we joined it. We are a drone industry, or a drone development business, and maybe you could click. Yeah, I don't see anything else. Yeah. This is what we envision. This is our challenge, and we want to create a drone of this size. This one is 4 meters wide and 3 meters long, and it's 80% of the eventual size of it. And I will tell you something more about it a few minutes later. But first, who are we? Maybe you could click. And then what do we do? Why do we do it? And what do we do? And our ambition. First, who are we? We are 3 entrepreneurs. 2 of us are working in the 3D printing industry. One of us has a company which prints large size printing, 2 meters by 2 meters by 2 meters, that size, and smaller, of course. And he's a tech engineer. Tristram is a machine developer and a drone racing enthusiast, and he will speak on the technology part of it. And I'm a former mayor, a technology nomad, and now a space consultant. And the reason we found each other is because we think different. We think in solutions, and that's the reason why we joined in the hackathon. If we have a problem, we like to reach out and find solutions, mainly with people who have other technology skills than we have. Why do we do what we do? It started with being deeply worried about what's happening in the Ukraine. That's where our name stems from, Smoothstone Dynamics. Smoothstone is, if you know the biblical story about David and Goliath, where a small sheep herder uses a small stone to kill a giant, and he uses one smooth stone, and that's the reason why we chose our name. We want to add something to to the struggle we see with David being Ukraine against the Russian bear, which is Goliath in this case. We saw drones making a difference. We saw what happened in the Black Sea, where repurposed jet skis chased away the Russian fleet in the Black Sea. We saw small cardboard drones from New Zealand, and we see DJIs with trigger mechanisms. In the last year, we saw drones coming from Iran and flowing over the Ukraine. But we didn't see much of an answer from our side. And we think differently, like I said, and we thought we can make a difference and we want to make a difference. And if we look at what the long-term space agenda from the Netherlands says, is that we need strategic independence in space, but also in defense. We want capability development, and we want attention to potential threats from countries like Russia and China. And we need collaboration. And that's the reason why we chose to create a drone, to build a drone, which helps the war ASAP, because the war itself kills 1,000 people every day, most of the time, much more than that. And we want to build a cheap drone for that. But a cheap drone must be expensive to intercept, because then you cripple the economy of the war. And we want to revolutionize the production. And we want to think as Elon on technology, not on politics. I rather say that too. So what do we need in technology? And that's the moment I give Tristan the floor. Tristan, go ahead.
Click, please.
It's
Thank you very much. So I'm here today to present you guys a challenge. We are in development of a drone, a rather large drone that can travel a very long distance, flies high, carries a lot of payload, and needs to place this payload precisely at this long distance. The part that's definitely in our hands, and it's in good hands, is that on the longer term, we want to produce a production capacity of maybe around 1 drone per minute. So that's 1,400 and something drones per day in order to make a real difference to this conflict. I would like to take this opportunity to paint you a little bit of a picture with this scenario. I think you should imagine it's dark out. Our team at the front line has a bunch of drones, let's say maybe 50. They have received orders from command to execute a certain mission. This mission is at a distance of almost 1,000 kilometers, will be executed at a height of 5 kilometers. And we expect to be behind the front lines where we expect loss of signal. Now, precision placement to ensure success of our mission is absolutely key. And this is the challenge that we face. At some point, we expect to go dark and we need to deliver. Click. For this challenge, we pose you a challenge where we would like to make use of the Raspberry Pi platform. Why? In general, this is a Linux platform, could have also been a BeagleBone or something else, but we see that this is an open, cheap, accessible platform, widely available, plenty in resources. Looking behind, it's also developed by a Western company, which helps us a lot. I think still it's produced in China, but it would provide us a platform to start from. The Raspberry Pi could be supported by visible spectrum cameras, infrared cameras. We could maybe add a bit of radar, IMU support, compass support, altimeters, global positioning systems, airspeed, with this toolbox, we think it should be possible to make a system that could, if necessary, survive the last mile on its own and deliver the parcel to the target. Click, please. So the challenge that we're posing you guys is to think of an idea how we can bridge this last mile with several sensors and options to develop a method, preferably a very creative method, of using all these sensors to locate the drone in space and time, plot the trajectory, and make sure we reach the destination on time. For the best 3 ideas, we would like to make available a budget of 500 euros for electronics and make sure that we deliver that on time. And then as a final test, we would like to real-life test these solutions on one of our big flying platforms. This is a quadcopter drone. It's slightly larger than you might be used to. The platform on its own weighs about 5 kilos, has a maximum speed of roughly 140 kilometers an hour and a range of several kilometers. We would like to choose these best 3 fitting ideas and put them to the test in an actual scenario. Click. Any questions, please?
Just I want to add a minor detail. Loss of signal at the end. You meant GNSS signaling, and that's why we want to join especially this hackathon, because it's also about the navigation and positioning information. So we add extra tools, but if you can solve the problem of spoofing and jamming, that would be awesome too. So that's a small add for it.
Thank you, bro.
And for the rest, if you have any questions, feel free to ask. This is, by the way, a render of how we envision our technology. This drone is not going to fly on its own. It's going to fly in swarms.
Someone come, thanks very much for your contribution to this webinar. I'm looking at the chat, and are there any questions which the audience want to address? Not now. You can always ask them in the email, because these email addresses are in the slides, which we will share, and you can ask them in a later stage. I have one question for you. You mentioned at the beginning the collaboration, which is key in this respect. Are you specifically looking for suppliers or certain technology, or what is your urgent need now?
The urgent need now is to come up with a complete working system where we can do long distance precise delivery of our parcel, as I like to call it. For quite a few of the problems that we are still facing, we are considering build or buy decisions. And quite frankly, seeing to the haste we have in supplying something to the ongoing war, we would prefer a buy. So I hope that answers your question.
Okay. So if there are no questions from the audience, then
I see
two questions even.
Two questions.
Two questions
On TK.
These are: have you explored how off-the-shelf IMU perform? I don't know. EK is...
Yes. If I answer the first question,
yes.
We have explored several IMU routes. We are also in consideration with a Dutch company that could provide such a system. But what worries us is the long distance drift of an IMU system. And we fear that even though there are some very good systems out there, over the distance and the speed that we are traveling at, think of speeds in the range of up to 500 kilometers an hour or more, we fear that we would still have a drift of maybe up to 100 meters, depending on the situation. Which, if you want to deliver your parcel at, say, at the pillar of a bridge or maybe some critical infrastructure at a precise location, that's way too much of drift.
Okay. Hopefully this answers the question. Then I see Tara's answering the question related to OpNet.
Yeah, maybe I'll try to use the opportunity to speak again. Of course, I was quickly typing just in case if we run out of time. I mean, we'd really like to encourage participants to come up with their own cases, something that makes them unique, because the most important, I believe, as a former participant of Hackathon, I participated in many and won a few. Our company won Copernicus Masters twice. So that something that is very important, that you need to look for the market where you could apply it. And because you need to understand the subject matter and feel the pain of the user before offering them a solution, right? In some cases, it could be defensive applications. In other cases, it could be civilian, like monitoring critical infrastructure, helping construction companies with expensive big projects, monitoring bridges for instabilities. There are many opportunities there. And yeah, among them, even helping agriculture in the Netherlands to do business, because yes, remote sensing monitoring is ancient, but the problem with Netherlands that 80% of the year we have clouds, so traditional optical tools do not work. So perhaps you could think up a better idea how to help them do the business, right? Hope it inspires you.
Thanks, Lars, for the addition and giving a bit of an insight. Yes, in the hackathon, we're going to develop prototypes or minimum viable products or any output which you create. And one of the elements which we also have a look at is how to come from an idea. You got some ideas in this webinar to a more business case. Business case is a bit of a strong word in this respect. So how you are going to address a market, or did you identify a market? So the jury will not only have a look at the technicalities of your solution, but also a bit of a future outlook on how to further develop this. And it could be for defense applications, security applications, and this is quite a large domain and a variety which is possible. So keep this also in mind. And in the hackathon, we will guide you with some canvases to get yourself organized in a way of thinking how to come from a rough idea to to develop the right approach to deal with the problem in the limited time you have. Okay. So are there any further questions? Then if not, then...
Oh, sorry, I had a question.
Yes, Dylan, go ahead.
Yeah, so for the smooth zone dynamics drone, like what is the precision that requirement for the no signal traveling?
We would like to, if possible, land in a square meter box.
Okay, fair enough. Thank you.
Okay. So this is a...
And is there also like, oh, sorry.
No, go ahead.
So you have like the Cassini challenge, but then you guys said you have your own challenge as well. Is there like a separate way to sign up for that, or does it just go automatically when you make a project?
Let me take the answer.
Okay.
It is. I will first explain that, Bram, and then you can specifically address your answer, or more from the smooth zone dynamics point of view. The Cassini hackathon has 3 main challenges. If you these are all very widely defined. So within those 3 main categories, you can build your own. So, and then like Bram and Tristram said, they face from their company point of view specific challenges, which fit in one of those 3, I would say challenge 1 or 2. They fit in these domains. So as long as you build your solution or service in one of these widely defined challenges, then you can specify according to the specific challenge, which is addressed in this respect by smooth zone dynamics. Wow.
Yeah, and it's more or less an extra prize. And that's the prize we hand out, is that we offer the possibility to test it in real life. And that's the ambition we have. We need working solutions. So this gift is also a gift to ourselves. So that's why we do it. And when you apply if you participate in the hackathon, you automatically are eligible to win the prize we offer.
Okay, thank you very much. That clears it up for me. Thank you.
Okay. Dylan, are you specifically looking for team members?
Was that a question?
I'm sorry, what did you say?
Do you specifically look for team members? Did you already register?
Yeah, I already have a group of people.
Okay,
So
good.
yeah.
Okay, good. Okay, then we're heading toward the end of the webinar. I would like to know if Mr. Mohammed Zarar is joining, maybe under an acronym which I do not know. Was he applied for a pitch of 1 minute? Well, looks like he couldn't make it. So in that case, then I would like to thank you all for participating in this webinar and asking the questions. And hopefully you receive the information which you were looking for. If not, then reach out, because we will send the slides of all presentations to each of the participants. And special thanks for the speakers, also for the revealing the prizes which they have in mind for the participants. So we stimulate this in the coming weeks while the registration is still open. Registration deadline is the 15th of November. So in case you want to reach out to other people, then be aware of this deadline. Okay, for now, thank you all, and hopefully I see you all in Zoetermeer on the 22nd of November. Thank you very much, and enjoy the evening. Bye-bye.
Thank you. Bye.